Conventional instructional design treats education as a linear, content-centric process. It is a system historically built to organize material for a physical classroom, where a teacher is present to guide the room. When institutions move online, many educators carry over a distinct assumption that if they simply upload rigorous academic content to a server, they have successfully created a rigorous online course. This relies on a flawed mechanism known as cold cognition. Cognitive researchers found that delivering raw facts independently of emotional involvement fails to trigger comprehension. The brain does not efficiently process or retain isolated data points that are devoid of context or emotional stakes. Deep learning only occurs when a learner recognizes a discrepancy in their existing knowledge and corrects it. That cognitive exertion cannot happen in a vacuum. It requires an environment with deliberately engineered architectural scaffolding. Building that scaffolding requires abandoning traditional instructional design and adopting learning experience design, or LXD. LXD accounts for the fact that a digital student is navigating a highly subjective internal state. It leads the designer to build empathetically around the human sitting alone at a computer. To execute this, we use the integrated framework for designing online learning experiences. This framework operates by mapping 4 internal psychological dimensions of the learner directly onto 5 external, actionable design aspects built by the instructor. This matrix provides the structural map for moving beyond passive content consumption and targeting specific cognitive outcomes. We have to construct this framework from the inside out, starting with the individual learner. Pre-existing subjective traits dictate the quality of any digital learning experience. What a person brings to the computer determines how they will interact with the material. This diagram maps out 11 evidence-based learner characteristics that impact engagement in an online environment. The strongest cognitive predictor of a student's initial success is their prior knowledge, which the brain stores in neural networks called schemas. If a learner has poorly formed schemas for complex content, that material will appear confusing and overwhelming. They require high structural support, redundancy, and explicitness early in the course. Beyond prior knowledge, the asynchronous digital space demands 2 specific survival traits: self-regulation and self-efficacy. Self-efficacy is the belief in one's own capability to complete a task. In an online setting, low self-efficacy directly amplifies procrastination. Students who feel incapable delay managing long-term tasks and devote their time to the wrong activities. If a course designer ignores these baseline characteristics, the resulting interface will create friction. That friction consumes working memory before the student even begins to learn the actual subject matter. Once we account for these pre-existing traits, we look at the active internal processes that occur the moment a student engages with the material. Surrounding the learner is the framework's inner ring, composed of 4 distinct learning dimensions. The cognitive dimension operates under a strict bottleneck, the severe capacity limits of working memory. Humans can only hold a small amount of new information at one time. A high density of raw content, combined with the burden of navigating complex software interfaces, quickly results in cognitive overload. To sustain that cognitive effort, the learner relies on the emotional dimension. Rigorous learning is not a purely analytical exercise. Deep learning requires what researchers call deliberately designed confusion. Presenting the right amount of friction forces the cognitive effort required to solve problems, which eventually yields the positive emotion of delight. To keep learners engaged through that necessary struggle, the digital interface must use appealing aesthetics and visual design. A clean, attractive environment reduces visceral frustration and improves a user's tolerance for difficult tasks. Cognitive processing will stall if the student becomes overwhelmed. Emotional scaffolding sustains the motivation required to push through complex material.
The third internal process is the behavioral dimension. This is the observable application of knowledge, where a learner closes the gap between knowing about a concept and knowing how to do it. A course must embed active learning strategies, like interactive simulations and virtual laboratories, to force students to produce behavioral outputs. Finally, we have the social dimension. In an online setting, students lack physical proximity, creating a unique challenge, establishing a perceptual presence in a digital void. The community of inquiry model shows that validating cognitive meaning requires both social presence, a personal connection to the community, and teaching presence, where the instructor actively facilitates the dialogue. A complete internal learning experience relies on all four of these dimensions operating simultaneously. Failing to engage any single quadrant weakens the structural integrity of the whole process. To manipulate those four internal dimensions, the instructor controls a specific set of external architectural tools. This view of the integrated framework shows the outer ring, the 5 actionable design aspects. The core principle of learning experience design is that these 5 external interfaces must be explicitly mapped to the psychological needs of the learner. For content interactions, simply delivering cognitive data is insufficient. The content must incorporate emotional elements, such as conversational, personalized language, to increase engagement and lower the barrier to entry. Learning activities must evolve past conventional reading assignments. They are reframed into generative tasks that challenge the student cognitively, emotionally, behaviorally, and socially all at once. Social interactions require explicit instructor immediacy. A teacher consistently responding and guiding discussions mitigates the isolation of the online environment and sustains student motivation. Assessments and feedback must function formatively. Detailed, continuous feedback manages the emotional dimensions of a student's self-efficacy and confidence, rather than just grading them at the end. The foundational layer of all this is the course structure and interface. As this chart highlights, this layout dictates the initial behavioral navigation and either reduces or exacerbates the cognitive burden of using the software. These 5 design aspects are the architectural levers. When pulled correctly, they engineer the exact conditions required for deep learning. The primary enemy of online course execution is fragmentation. This happens when content, activities, and interactions are presented as a list of loosely connected checklists rather than a unified syllabus. To combat this, we apply the integration design principle. This chart emphasizes the need for a holistic approach, tying all 5 design aspects together into a single continuous loop. Instructors achieve this by using pedagogical wrappers. By writing brief contextual notes around a reading unit or a quiz, the designer explicitly explains to the learner exactly why the task matters and how it connects to the broader goals. Furthermore, purposefully interweaving social interactions directly into reading assignments and cognitive tasks ensures the student is never learning in total isolation. An integrated online course operates as a single cohesive ecosystem. It functions as a dynamic environment, not a static file repository. Executing this framework correctly relies on one non-negotiable requirement: learner empathy. Empathy in this context is practical. It means the designer actively adopts the perspective of the learner, anticipating their cognitive load constraints and their emotional state before building the syllabus. Deep learning in a digital space is a fragile state. Achieving it requires meticulous environmental engineering. Successful online teaching relies on architecting an ecosystem that sustains a student's motivation, manages their cognitive load, and demands the active application of knowledge. Transitioning from content-centric instructional design to learning experience design creates the holistic, learner-centered environment required for modern digital education.